we now discuss the solution of 5 multiple choice questions from the section Binomial Theorem that have appeared in the January 2024 session of Joint Entrance Examination Main. These examinations were held from 27th January 2024 to 1st February 2024. Now we take up the first question, and this question has appeared in the Joint Entrance Exam Main held on 27th January 2024 in the first shift. The given problem is n-1 CR is equal to k square minus 8 in brackets multiplied by n CR plus 1 if and only if. We are given 4 options, and these options will tell you the range for this k. Now the given question is, we are given n-1 CR is equal to k square minus 8 in brackets multiplied by n CR plus 1 if and only if. We have to find out the appropriate range for this constant k. And this question seems to be a question from the section permutations and combinations, but somehow we have categorized under the binomial theorem. Let's now discuss the solution of the problem in detail. Note that R is a natural number and it also takes the value R is equal to 0. So R belongs to n union the singleton set consisting of 0. So now n-1 CR, when it is defined if and only if n-1 is greater than or equal to R. That is n-1 greater than or equal to R, that is n is greater than or equal to R plus 1, that is R plus 1 by n is less than or equal to 1, and R plus 1 by n is greater than 0, obviously. Agreed. So n-1 CR is defined if and only if 0 less than R plus 1 by n is less than or equal to 1. Now consider the given one. n-1 CR is equal to k square minus 8 into n into CR plus 1. n CR plus 1. This is if and only if. We are writing the equality, therefore it is if and only if. K square minus 8 is equal to n-1 CR by n CR plus 1. Now write the definitions of n-1 CR and n CR plus 1. n-1 CR is n-1 factorial by r factorial into n-1 minus r factorial by n CR plus 1 definition n factorial by r plus 1 factorial multiplied by n minus of in brackets r plus 1, that is n minus r minus 1 factorial. By cancelling the appropriate terms, we get r plus 1 by n. Agreed. But this r plus 1 by n is what? 0 less than r plus 1 by n less than or equal to 1. So for this, this is if and only if 0 less than k square minus 8 less than or equal to 1. Why? Because r plus 1 by n is 0 less than r plus 1 by n less than or equal to 1. So now adding the 8 throughout, if and only if 8 less than k square less than or equal to 9. So this will be if and only if k belongs to 2 root 2 to 3, 2 root 2 open to 3 closed. So it's a semi-closed interval. Union, if you take the other way around, that is the other values, and that will be union minus 3 to minus 2 root 2. It is again semi-closed, closed at minus 3 and open at minus 2 root 2. So k belongs to this if and only if 8 less than k square less than or equal to 9 if and only if this happens. Now look at your answers. So k belongs to open semi-closed interval 2 root 2 to 3 means 2 root 2 less than k less than or equal to 3. That is precisely appearing in the option 4. Option 4. So the answer to this question is option 4. So that is the detailed discussion of the solution of the given question. I am sure that you have understood the solution of this problem. Let's move to the next question. That is the second question, and this question has appeared in the JEE main exam held on 27th January 2024 in the first shift. The given question is, if capital A denotes the sum of all the coefficients in the expansion of 1 minus 3x plus 10x square whole to the power of n, and capital B denotes the sum of all the coefficients in the expansion of 1 plus x square whole to the power of n, then we are given 4 options. So we have to find out the appropriate relationship between A and B. Capital A is the sum of the coefficients, sum of all the coefficients in this expansion, first expansion, and capital B denotes the sum of all the coefficients in this second expansion, and required to find the correct relationship between A and B. Let's now discuss the solution of the problem in detail. We have the first one, 1 minus 3x plus 10x square whole to the power of n is equal to, when you expand, you will get the expansion as a sigma AR x power r. That means the coefficient of x to the power of r is AR. The summation runs r is equal to 0 to 2n. Why? Because it's a quadratic. X square term is that to whole to the power of n. When you expand it, you will get the polynomial whose degree is 2n. So this is sigma r equal to 0 to 2n AR x power r. And 1 plus x square whole to the power of n, when you expand, you will get sigma r is equal to 0 to 2n BR x power r. Note that it is given capital A as the sum of all the coefficients. That means sum of all AR. In the expansion 1 minus 3x plus 10x squared whole to the power of n. How do I get sum of all the coefficients? If you substitute x is equal to 1, you will get sigma AR. So that is sigma r is equal to 0 to 2n AR. That is the sum of the coefficients. So capital B, the sum of all the coefficients in the expansion of 1 plus x square whole to the power of n, the sum of all the coefficients in the expansion of 1 plus x square whole to the power of n is sigma BR. So now how do I get sigma AR? So now put x is equal to 1, then you will get sigma AR is equal to, put x is equal to 1 in this. This is 1 minus 3 into 1 plus 10 into 1 square. That is 1 minus 3 plus 10 whole to the power of n. That is, when simplified, it is 8 power n. And sigma BR is, put x is equal to 1 plus 1 whole to the power of n, that is 2 power n. So the first one, sigma AR is capital A, So therefore capital A is 8 power n and sigma BR is capital B. Capital B is equal to 2 power n. Now A is equal to 8 power n. 8 is written as 2 cube to the power of n, that is 2 power 3 n, that is equal to 2 power n whole cube, whereas 2 power n is b cube, that is A is equal to b cube. So let's look at our options. In our options, A is equal to b cube appears against the option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of the given problem, and it is definitely an easy question. I am sure that you have understood the solution of this problem, and we move to the next question, that is the third question. This question has appeared in the JEE Main exam held on 30th January 2024 in the second shift. The given question is, suppose 2 minus p, 2 minus alpha and alpha are the coefficients of 4 consecutive terms in the expansion of 1 plus x to the power of n. Then the value of p square minus alpha square plus 6 alpha plus 2p equals. We are given 4 options. We are given 2 minus p, 2 minus alpha are the coefficients of the 4 consecutive terms in this expansion 1 plus x to the power of n. Required to find the value of p square minus alpha square plus 6 alpha plus 2p. Let's now discuss the solution of the problem in detail. We have 1 plus x to the power of n. When you expand by means of binomial, it's a binomial, but using the binomial theorem, sigma r is equal to 0 to n, ncr into x power r. Right. Now let the coefficients of the 4 consecutive terms in this expansion be, let us say, ncr consecutive, ncr plus 1, ncr plus 2, ncr plus 3. But it is given to us 2 minus p, 2 minus alpha are the coefficients of the 4 consecutive terms. Right. So therefore 2 minus p must be equal to ncr. So ncr is equal to 2 minus p, ncr plus 1 is equal to p, ncr plus 2 is equal to 2 minus alpha, ncr plus 3 is equal to alpha. So the 4 equations have come. Right. So if you add the first two, you will get 2 minus p plus p, that is pp cancels 2. So this will be ncr plus 1 is 2. If you add these third and fourth, you will get alpha cancels, ncr plus 2 plus ncr plus 3 is equal to 2. Agreed. Now ncr plus 1, use the Pascal's identity, then you will get n plus 1 cr plus 1, that is equal to 2. Again use the Pascal's identity here, ncr plus 2 plus ncr plus 3 is equal to n plus 1 cr plus 3 is equal to 2. So use the Pascal's identity, you will get n plus 1 cr plus 1 is 2. From here n plus 1 cr plus 3 is 2. Agreed. Now they are equal. So n plus 1 cr plus 1 is equal to n plus 1 cr plus 3. These two are equal. Either r plus 1 is equal to r plus 3, that is r plus 1 is equal to r plus 3 is inconsistent, because 1 is equal to 3 you will get, which is absurd. Therefore the n plus 1 must be equal to the sum of r plus 1 and r plus 3. So r plus 1 plus r plus 3 is equal to n plus 1, that is equal to n is equal to 2r plus 3. So take this n is equal to 2r plus 3 and get into any one of these two equations. N plus 1 cr plus 1 is 2. Let's see what happens. N plus 1 cr plus 1 is 2. Yes. We have n is 2r plus 3. So 2r plus 3 plus 1, 2r plus 4, cr plus 1 is 2. Now the question is, when NCR, suppose you talk about NCR, the binomial coefficients, when an NCR is 2, this is only possible when n is 2 and r is 1. So 2r plus 1 is, this will imply 2r plus 4 is 2 and r plus 1 is 1. Why? Because NCR is 2 if and only if n is equal to 2 and r is equal to 1. Therefore, 2r plus 4 must be 2, r plus 1 must be equal to 1. Now, if you look at them, r plus 1 is equal to 1 will give you r is equal to 0. Take the r is equal to 0 and substitute in 2r plus 4 is equal to 2. You will get 4 is equal to 2, which is absurd. That means this gives the inconsistent results. So this is inconsistent. And that means the data given is inconsistent. Therefore, we cannot go further. Therefore, we stop here and we move on to the next question. That means for this question, you cannot find the value of p square minus alpha square plus 6 alpha plus 2p from these options. So therefore, there is no answer for this. We stop here and go to the next question. The next question, question number 4, has appeared in the JEE Main exam held on 31st January 2024 in the first shift. Let small a be the sum of all the coefficients in the expansion of 1 minus 2x plus 2x square whole to the power of 2023 multiplied by 3 minus 4x square plus 2x cube whole to the power of 2024, and b is equal to limit extends to 0 of a quotient whose numerator is integral 0 to x log of 1 plus t by t to the power of 2024 plus 1 dt by the denominator x square. If the equations cx square plus dx plus e is equal to 0 and 2bx square plus ax plus 4 is equal to 0 have a common root where c, d, e are real numbers, then d is to c is to e equals, we are given 4 options. We are given a is the sum of all the coefficients in the expansion of 1 minus 2x plus 2x square whole to the power of 2023 multiplied by 3 minus 4x square plus 2x cube whole to the power of 2024. And b is given to be limit extends to 0 of the quotient whose numerator is integral 0 to x log of 1 plus t by t to the power of 2024 plus 1 dt by the denominator is x square. It is given cx square plus dx plus e is equal to 0 and 2bx square plus ax plus 4 is equal to 0 have a common root where c, d, e are real numbers. Required to find the value of d is to c is to e. Let's now discuss the solution of the problem in detail. We have 1 minus 2x plus 2x square whole to the power of 2023 multiplied by 3 minus 4x square plus 2x cube whole to the power of 2024. And this when you expand, you will get the highest power of x will be x to the power of 2 into 2023. When you expand the second one, the highest power of x will be 3 into 2024. Therefore, in the sum of all these, so what do we get? What do you get? Because this is a multiplication. This is a multiplication. Therefore, x to the power of 2 into 2023 plus 3 into 2 to the power of 3 into 2024. Therefore, the expansion will be sigma r is equal to 0 to 2 into 2023 plus 3 into 2024 AR x power r. Agreed. Agreed. Now put x is equal to 1 in this. Then you will get 1 minus 2 into 1 plus 2 into 1 whole to the power of 2023 into 3 minus 4 into 1 plus 2 into 1 whole to the power of 2024 is equal to sigma r is equal to 0 to 10,118 AR. That is this is 3 into 2023 plus 3 into 2024 will be this amount. Right. So therefore sigma AR is 1 into 1. 1 into 1, that is 1. So sigma AR, so A is the sum of all the coefficients. Therefore sigma AR, sum of all the coefficients is 1. Therefore A is the sum of all the coefficients in the expansion is 1. Agreed. Now let's move to the B. B is equal to limit x tends to 0 is given to be of a quotient whose numerator is this integral by x square. Now as limit x tends to 0, the numerator is integral 0 to 0. X is 0, 0 to 0. Integral 0 to 0 is 0 by x square 0. Therefore it's a 0 by 0 form, which is an indeterminate form. To evaluate this one, we will apply L'Hopital's rule. That will be equal to limit x tends to 0 of the derivative differential of the numerator. This is integral 0 to x ft dt. When you differentiate it, you will get fx. Fx will be log of 1 plus x by x to the power of 2024 plus 1 by the derivative, the differential of x square is 2x. We have used the L'Hopital's rule. Agreed. Now this we have written as 1 by 2 into limit x tends to 0 1 by x to the power of 2024 plus 1 into limit x tends to 0 log of 1 plus x by x. And in this 1 by 2 into limit x tends to 0 of this one is 1 into limit x tends to 0 log of 1 plus x by x will remain. Now it's again 0 by 0 form. Use the L'Hopital's rule. Then you will get 1 by 2 into limit x tends to 0. Derivative of log of 1 plus x is 1 by 1 plus x by the derivative of x is 1. Now apply limit x tends to 0. This will be 1 only. This is x tends to 0. This is 1 only. This is 1 only. So what is equal to 1 by 2. So B is equal to 1 by 2. Thus, we have obtained A is equal to 1 and B is equal to 1 by 2. We continue in the next slide. So that is what we have. Now, given the equations cx square plus dx plus e, where c, d are real numbers, 2bx square plus ax plus 4 is equal to 0, have a common root. Now, b is equal to 1 by 2, 2b will be 1. So, a is 1. 2bx square plus ax plus 4 is equal to 0 will be x square plus x plus 4. That will be the second equation. So, the equations cx square plus dx plus e is equal to 0 and x square plus x plus 4 is equal to 0 have a common root. Let's first of all consider this equation x square plus x plus 4 is equal to 0. And if you see the discriminant, it is negative. That means it will give you complex roots. So the roots are given here. These are complex roots a plus or minus ib. Now suppose that the equation cx square plus dx plus e is equal to 0 and the second equation x square plus x plus 4 is equal to 0 have a common root, let us say a plus ib, one of them. So That means you have a common root means a plus ib is also a root of cx square plus dx plus e is equal to 0. So what is this equation? It is a quadratic equation whose coefficients are all real. And a plus ib is a complex root of this, and complex roots occur in pairs because the coefficients are all real. Therefore cx square plus dx plus e will also have a root a minus ib. Since cx square plus dx plus e is equal to 0 is a polynomial equation with real coefficients, complex roots occur in conjugate pairs, so a minus ib is also a solution for that. So thus a plus or minus ib are the roots of cx square plus dx plus e is equal to 0. So that means both the equations have the same roots. But this is a quadratic equation, that means they must be precisely the same equations, or one equation is a multiple of the other equation. That means the coefficients must be proportional. That means the coefficient of x square c by the coefficient of x square 1 is equal to d by 1 is equal to e by 4. That is, we want d is to c is to e, then I will write d by 1 is equal to c by 1 is equal to e by 4. That is equal to d is to c is to e is 1 is to 1 is to 4. So let's look at our options here. Our answer 1 is to 1 is to 4 appears against option 3. Therefore the answer to this question is option 3. That is the detailed discussion of the solution of the problem, and I am sure that you have understood the solution of this problem. Move to the next question, that is the last question, and this question has appeared in the JEE Main exam held on 1st February 2024 in the second shift. The given question is, let m and n be the coefficients of the 7th and 13th terms respectively. M and n are the coefficients of the 7th and 13th terms respectively in this expansion. That is 1 by 3 of x to the power of 1 by 3 plus 1 by 2x multiplied by x to the power of 2 by 3 whole to the power of 18. Then n by m whole to the power of 1 by 3 is, we are given 4 options. M and n are the coefficients of the 7th and 13th terms respectively in this expansion. Then required to find the value of n by m whole to the power of 1 by 3. Let's now discuss the solution of the problem in detail. Agreed. Now we recall the general term of the expansion of x to the power of x plus a whole to the power of n is given by tr plus 1 is equal to ncr into x to the power of n minus r into a power r. We have t7, that is t6 plus 1 will be equal to 18c6 into 1 by 3 into x to the power of 1 by 3 whole to the power of 18 minus 6 into 1 by 2x to the power of 2 by 3 whole to the power of 6. Simplifying, you will get 18c6 is equal to 1 by 3 power 12. This is 1 by 2 power 6. And t13 is t12 plus 1 is 18c12 into 1 by 3 x to the power of 1 by 3 into n minus r 18 minus 12 into 1 by 2x to the power of 2 by 3 to the power of r, that is 12. After simplification, you will get 18c12 multiplied by 1 by 3 power 6 multiplied by 1 by 2 to the power of 12 into x to the power of minus 1 minus 6. Yes, that's right. Now we want what? N by m. M is, what is m? M is the coefficient of the seventh term. So that is, coefficient of the seventh term is 18C6 1 by 3 12 into 2 to the 1 by 2 to the power of 6. T power 7 is independent of x. N is the coefficient of t to the power 13. The coefficient is 18C12 into 1 by 3 to the power of 6 into 1 by 2 to the power of 12. So we want n by m. So let's now take n by m, the coefficient of t13 by coefficient of t7. Now put the terms, and 18C12 cancels with 18C6 because NCR is equal to NCn minus R. That is 18C6 is equal to 18 minus 6, that is 12. This cancels. And after simplification, we get 1 by 2 to the power of 6 by 1 by 3 to the power of 6, that is 3 by 2 to the power of 6. This is n by m. Now, if I take n by m whole to the power of 1/3, then it will be 3 by 2 whole square. Agreed. 3 by 2 whole square means 9 by 4. Let's look at our options. Our answer appears against option 1. So, option 9 by 4. Sorry, it's not 4 by 9, it is 9 by 4. So, option 4. So, it appears against option 4. So, the answer to this question is option 4, and it is definitely an easy question. And that is the end of the discussion of all the 5 questions, all the 5 multiple choice questions that are asked in the January 2004 session of JEE Main Examination under the section Binomial Theorem. I am sure that you have understood the solutions of all these 5 questions, and I wish you all the best. Thank you.